Hello, myself Professor V.K. Sarkara, College of Agriculture, MOTA BHANDARIYA, Junagadh Agriculture University, Junagadh. This is the course of farm machinery and power of the first semester Agri Engineering 3.2. We will study the IC engine and its parts in this chapter. First, we see the definition of machine in British language. In the British, machine is defined as an assembly of interconnected components arranged to transmit or modify force in order to perform useful work. Means here various components are assembled and incorporated each other for the purpose either to transmit the motion or to modify the force. The ultimate aim of this is to perform useful work. Suppose here you can see that this is the engine. We may say this is the tractor engine. This tractor engine is meant to transmit the force or power that has been germinated within the engine, and it has transmitted and modified to perform useful work. Suppose we are making seed bed by the suitable implements using this tractor power. So we can say here tractor engine is made of interconnected components and assembled in such a way that it transmitting the motion as well as the force is modified to, we can say, run the implement for various agriculture purpose. Here this machine is performing the seed preparation work. So simply if we see in we can say synchronized way, this is the engine of the tractor. Whatever we can say energy or power produced by the engine, that can be transmitted further by engaging the clutch with the engine. The clutch, if the clutch is engaged, then it goes to the transmission system, and first it goes to the gearbox. Here various types of gear are available: first, second, third, fourth, reverse. That through the gearbox we can decrease or increase the speed. Then this decrease or increase speed can be achieved to the drive shaft, and through that drive shaft it goes to the rear wheel. So if we want to run the tractor on the road or in the field, then this may be done by this transmission system, and we can move further ahead. And whatever implement or instrument that has been attached with the tractor, that works. So our tractor engine do the or we convert the power to perform the useful work. Now, second definition: any machine or electric device that automatically perform task or assist in the performing task. Means either it may be mechanical device, or we can say it is electrical device that automatically perform the task or assist to perform the task. See here, this is our IC engine, diesel engine with centrifugal pump. This is diesel engine and this is centrifugal pump. This is, we can say, mechanical machine. So as and when with the use of diesel, with using the diesel as a fuel, diesel engine works and it operates the centrifugal pump. The centrifugal pump lift the irrigation water from the well, or we can say from the bore. So it performs the task of lifting the water from the well or bore. See here, this is electric motor. This motor is run through electricity, and this is we can say submersible motor or submersible pump. These both are run with the electricity, and this submersible electric motor acts as a electrical device and lifts the water from the well. So this device is called, we can say it's a electrical machine or electrical device. Same way, this submersible pump acts as a electrical device and lift the water from the either from the bore or from any other sources. So we can say this is electrical machine or electrical device. Now mostly we have to go, we have to study heat engine. So let me define heat engine. Heat engine is a machine which converts heat which is developed by burning the fuel into useful work. Means in the heat engine we are burning the fuel for performing or for getting the fuel energy into useful work. So this machine converts burning of fuel in terms of heat, and that it may be converted into the useful work. In other words, it can be said that heat engine is an equipment which generates thermal energy and transforms it into mechanical energy. See, in the IC engine, we are using fuel as it may be diesel or petrol. So this fuel burnt in the engine and it generates the heat, generates the thermal energy. This thermal energy is transformed into mechanical energy by the reciprocating motion of the piston, and this reciprocating motion of the piston is then we can say, suppose see here, this reciprocating motion of the piston is then transmitted through the connecting rod to the crankshaft, and we can say if the rotationary motion of the crankshaft is then utilized for further useful work. See, heat engines are of two types: external combustion engine and internal combustion engine. Here, the example of both are given. First, we see the external combustion engine. External combustion means combustion is not within the engine. That is external combustion engine. See here, steam engine is given. This is the part, we can say this is the boiler parts, and this is the working cylinder. Here, coal is burnt and vapor is produced, but this vapor is produced outside the engine cylinder. So this is external combustion engine. We will study detail the internal and external combustion engine later on. See here, external combustion engine. It is the engine designed to drive its power from fuel burnt outside the engine cylinder. See, this is this steam engine. Here, this is the boiler unit. In the boiler unit, here fuel is burnt in the boiler unit, which is outside the engine cylinder. See here, engine cylinder, and we are burning the coal as a fuel in the boiler unit. Burning the fuel, we are producing steam, and this steam is utilized for producing useful work. See here combustion process uses heat in the form of steam, which is generated in the boiler, placed entirely separate from the working cylinder. Means this is our working cylinder. Here we are using steam as a working substance, but this steam is produced outside the working cylinder. See, this is boiler unit, which is not the part of we can say our working cylinder. So whatever steam is produced, that has been utilized to produce the useful work. See, from the figure we can see that here, as and when this inlet valve opens, then steam comes in the cylinder and it forces the cylinder. So this rotates the wheel for the forward motion of the engine. During the exhaust stroke, this exhaust valve open and all the exhaust gases goes out outside the engine in the atmosphere. So here with the valve arrangement, the engine runs over the, we can say, railway track. So this is the external combustion engine. Here steam is introduced in the working cylinder for producing the useful work through this valve. This valve is called inlet valve, and whatever exhaust gases that goes out through the exhaust gases, exhaust valve in the atmosphere. Now we will see the internal combustion engine. In internal combustion engine, the combustion of fuel takes place inside the cylinder and heat is generated within the cylinder of the engine. See here, these are the fuel injector. This is the four cylinder engine. So there are fuel injector for each and every cylinder. This fuel injector inject the fuel at proper time in the combustion chamber, and this fuel is burned due to the high compressed air which has more temperature. So there is, in the, we can say, compression ignition type of engine, there is no need to have sparking arrangement or any other arrangement to burn the fuel. So in internal combustion engine, the combustion of the fuel takes place inside the engine cylinder. Here this is the upper portion, or we can say top portion of the cylinder. We may consider as a combustion chamber where the fuel is burnt. The generated heat is converted into useful work by the piston constrained within the cylinder. Here the piston rotates forward and backward motion in the cylinder. So whatever energy that has been produced through the burning of the fuel, that is converted into useful power or useful work by the piston, pressurizing the piston and transmitting it by the connecting rod to the crankshaft. The motion of the piston rotates a crankshaft with the help of connecting rod. See here, this crankshaft is rotating. By the rotationary motion that has been given by the connecting rod, which is attached with the piston. The heat generated within the cylinder acts as a working substance that supply the energy to the piston. Hence, the name is given as internal combustion engine. Means whatever working substance, that is working substance here is the heat that has been supplied by the engine cylinder, or it is produced within the engine cylinder. Hence, this is called the internal combustion engine. See here, this is the boiler unit where fuel is burnt in the form of coal. Fuel is burnt and vapor is produced. That vapor is used in the working cylinder. So whatever we can say working substance, we can say water vapor that has been produced outside the cylinder. So it is called the external combustion engine. And here by the fuel injector, at the proper time fuel is injected in the cylinder, and due to high compressed air, hot air, the fuel is burnt inside the engine cylinder and produce the, we can say, pressure on the top of the piston and rotate the piston downward. That we can say that is the power stroke produced in the engine. So here we can say our working substance heat is produced within the engine cylinder. So it is internal combustion engine. That heat is produced by the burning of fuel. Now two types of we can say engines are there. Four-stroke cycle engine, that is generally known as a diesel engine, and two-stroke cycle engine, that is generally known as petrol engine. We will study in detail later on. As we studied so many things about engine system, so these are the different parts of the engine. We will go in detail each and every after some time. There are two ways in which combustion take place in the cylinder. Here we have seen that our fuel is burnt inside the cylinder, but the combustion of this fuel takes place in the cylinder like two ways. First, constant volume combustion, that is called CVC, constant volume combustion. Here word constant volume is applied. So see how it, why it is used. By rapid explosion of the air fuel mixture within the cylinder, when it is ignited by a spark plug, is called constant volume combustion. Means here air fuel mixture within the cylinder is rapidly ignited. So using the spark plug, we are suddenly ignite the air fuel mixture, and due to the sudden burning, there will be rapid explosion. So at that time, volume remain constant. So it is called the constant volume combustion. This is called constant volume combustion because when the combustion takes place, the volume of the combustion chamber, that is working cylinder, is almost constant. Because here rapid explosion is produced. So due to the rapid explosion of the air fuel mixture, or we can say our fuel, there will be no increase in the volume. Volume remain constant. So it is constant volume combustion. Generally in the petrol engine, or we can say our two-stroke engine, constant volume combustion takes place. The burning or ignition of the fuel is done by spark plug in the engine. Now second, constant pressure combustion, CPC. Combustion takes place by slow burning when the fuel is injected into highly compressed heated air contained in the cylinder. Means in the four-stroke engine, during the compression stroke, air is compressed within the clearance volume of the cylinder, and when the piston is at the top dead center, at the same time fuel is injected inside the cylinder. So here hot air is there which has very much high temperature, and fuel is injected with the injector. See here fuel injector is there, that inject the fuel when the piston reaches top dead center at the time of compression stroke. So here burning of fuel takes place slowly, or we can say combustion of the fuel takes place slowly within the cylinder. So it is called constant pressure because pressure do not rise suddenly. So it is almost, we can say, pressure remain constant. This is called constant pressure combustion because when the combustion takes place, the pressure in the cylinder is almost constant. Because here the burning of fuel is take place slowly, so pressure within the combustion chamber remain almost constant. Generally in the four-stroke engine cycle, say our diesel engine, this constant pressure combustion cycles works. Now we will see the engine classification, means different types of engine. The classification depends upon different parameters or different criteria. Suppose first we see the cycle which has been used in the engine. So first we say engine cycle. According to engine cycle, engine may be classified as Otto cycle, or we can say for SI engine, spark ignition engine. Then second is diesel cycle or ideal diesel engine. Then dual cycle or actual diesel engine. Then second classification criteria is number of stroke, means either it is four-stroke engine or two-stroke engine or four-stroke engine. Then which type of fuel used in the as a we can say combustible material, or we can say as a working fluid, that is fuel used. The engine may be classified as petrol engine, diesel engine, coal or wood engine, or we can say CNG, PNG, biomass, etc. types of gases. Now, fourth, according to the types of ignition, means which type of ignition system is there within the engine. According to that, spark ignition. In this spark ignition, there are two types of ignition system: battery ignition system and second is magneto ignition system. And another type, that is compression ignition. Generally, in the diesel engine, we can say ignition system is compression ignition system. Now, according to number and arrangement of cylinder, means how many number of cylinders are there and how the cylinders are arranged, how it is arranged in the cylinder. According to numbers, we can say single cylinder or multi-cylinder engine. And according to arrangement of the cylinder, in say it may be inline, V-type, radial, opposite cylinder, opposite piston. These are the various types of arrangement of the cylinder and piston. Then according to valve arrangement, valve arrangement, it may be categorized in two ways. That is valve or port design. That may be puppet or rotary or reed type. Then second is valve location. According to valve location, how it is located, in which fashion it is located. In T fashion, in L fashion, or S F fashion, or I fashion. Accordingly, we can categorize as a T valve arrangement, L valve arrangement, or T engine, L engine, F engine, I engine, etc. Then types of cooling. Depending upon the cooling system used in the engine, there are two types. That is, first is we can say water cooled engine, that is water cooling, and air cooled engine, that is air cooling. Air cooling may be of direct or indirect air cooling, maybe either direct air cooling or indirect air cooling. So this is the classification of the engine. Here a clear figure of the engine is given. We will see as and when we need to have, but simply I will give the introduction of various parts of the engine. Suppose this is the piston. Piston is connected with the connecting rod to the crankshaft. This crankshaft it rests in the crankcase by the crank bearing, and connecting rod is also attached with the crankshaft with the crankshaft bearing. The piston slides in the engine cylinder in the reciprocating motion, means upward and downward motion. See here, there is a different valves for a particular cylinder. There are two valves. One may be inlet valve and second may be exhaust valve. This valve is operated by the camshaft mechanism. This is the camshaft, and all about attached parts are of the valve operating mechanism. For lubricating the engine, here this is the oil pan in which, or we can say oil sump in which oil is there. If the engine is of bigger size, then oil lift pump is used for pressurizing the oil to lubricate in different parts of the engine. So many other systems are there in the engine. Suppose for the cooling, there may be cooling system, then lubricating system. We will see later on. Now, from this figure, just we go to the different parts of the IC engine. This is the exploded view of the engine. See here, the uppermost part is the cylinder head cover. This is the cylinder head. This is the cylinder head cover. With the cylinder head, this inlet manifold as well as exhaust manifold are attached. Cylinder head is attached with the cylinder block with the we can say head gasket, so there will be no leakage of gases. In the cylinder block, there are number of cylinders or cylinder bores according to the, we can say, how much cylinder are there. Means 2 cylinder, 4 cylinder, 6 cylinder. According to that, cylinder bores are there in the cylinder block. At the lowest end, there is a oil pan, or we can say oil reservoir, which is attached with the engine block. In the oil pan, there is lubricant oil, which is either lifted or thrown to lubricate the various parts that are reciprocating or working within the engine. We will see detail each and every part. First, we will see cylinder. See, this is the piston and this is the cylinder. Inside the cylinder, piston rotates as a reciprocating motion. Let me define the cylinder. It is a part of engine which confines the expanding gas and forms the combustion space for the combustion of the fuel. Means cylinder acts in two ways. It confines the expanding gas after burning the fuel, and also the combustion of fuel takes place within the cylinder. Secondly, it provides space in which piston operates to suck the air or air fuel mixture. Means, suppose our engine is 4-stroke engine, that in that case, during the suction stroke, or we can say intake stroke, air is sucked through the inlet valve in the engine cylinder. So, it provides the space to the sucked air in the 4-stroke engine, and in the 2-stroke engine, or we can say in the petrol engine, air fuel mixture is drawn in the cylinder for the burning. The piston compresses the charge inside the cylinder and receive energy from the burnt expanding gas inside the cylinder for further useful work. Means, after compression stroke, either fuel is burnt due to high compressive and pressure and high temperature in the 4-stroke engine, or it may be ignited by the spark plug in the 2-stroke engine. So, this burning of fuel gets the expanded gases, gives the expanded gases, and that expanded gases pressurize the piston, and this piston receives the energy from this expanded gases, and it reciprocate in the cylinder. Thus, piston gives the useful work to the connecting rod, and that is transmitted to the crankshaft. So, ultimately, engine cylinder acts as a combustion chamber, and also it provides the space for expanding gases, and then the pressure of the expanded gases is transmitted to the piston. Cylinders are usually made in high grade cast iron. Means, generally high grade cast iron are used for making the cylinder. Now, second part is cylinder head. It is a detachable portion of an engine which covers the cylinder and includes the combustion chamber, spark plug, and valves. Means, this is the detachable portion. See here, cylinder head cover, and this is cylinder head. Over the cylinder head, there is a cylinder head cover fitted with the tightly with using the proper gasket in between cylinder head cover and cylinder. Cylinder head is a detachable part. In cylinder head covers three things. It covers the combustion chamber. Means, in the advance we will see the, we can say, clearance volume. That clearance volume exists within the cylinder head. That is the combustion chamber, and also there is a spark plug in the two-stroke engine, or we can say petrol engine. In the four-stroke engine, there may be we can say fuel injector instead of spark plug. In the petrol, we can say our diesel engine. So either if our engine is two-stroke engine, then there may be spark plug, and if our engine is four-stroke engine, then in that case there is we can say injectors in the engine cylinder head, and also valve, inlet and exhaust valve also there for each and every cylinder. There may be one inlet valve and one exhaust valve in case of four-stroke engine. Now, third part is the engine cylinder. Engine block. See, this is the engine block. The engine block, from the picture we see that there is a 1, 2, 3, 4 cylinder bore, or either it may be directly, if cylinder sleeve is inserted, then it may be called as a cylinder. Otherwise, we can insert cylinder inside, and then it acts as a cylinder. So this is cylinder block. See, it is the solid casting which includes the cylinder. See, cylinder block is a solid casting which includes number of cylinders. If our engine is four-stroke, 4 cylinder, then there is a 4 cylinder. So it includes the cylinder. And water jackets means inside the porous space there may be element of circulating the water around the cylinder to absorb the heat, that has excess heat that has been generated during the burning of the fuel. So water jackets are also there in the engine block. Maybe cooling fins in case of two-stroke engine, or we can say petrol engine. Fins, we will what is fins? That is, we can say, extended portion to give more space or more surface area for cooling the two-stroke engine, or we can say petrol engine. Fins are there. We will see in the further during the lecture. Now, fourth is the liner, cylinder liner or sleeve. Means in the engine block there is a space for cylinder. So in that cylinder we either fit the cylinder liner or sleeve. See, this is the cylinder liner, and this is the cylinder sleeve, and this is the cylinder liner. If we want to have, we can say, minimum replacement cost of the cylinder liner, then instead of cylinder liner we use the cylinder sleeve. Let me see. It is the cylindrical lining, either wet or dry, which is inserted in the cylinder block in which the piston slides. Means for the frictionless sliding, or we can say with the friction-free sliding, cylinder lining is inserted within the core of the cylinder block. So if our engine is 4-cylinder 4-stroke engine, then there may be 4 cylinder bore, and in the 4 cylinder bore we have to insert either a 4 cylinder sleeve or 4 cylinder liner. Cylinder liners are fitted in this cylinder bore, and they are easily replaceable. As I have told that if our engine is 4-cylinder 4-stroke engine, then in that case there are 4 bores in the cylinder block. So in each and every cylinder bore we have to insert cylinder liner separately, and this cylinder liner or cylinder sleeve are easily replaceable. So during the working, if gets certain, we can say, lining or something in terms of damage, then it may be easily removed and new lining or new sleeves may be inserted with the less cost. Liners are classified as dry liner and wet liner. That depends upon the characteristic of cooling system around the cylinder. So if there is no water circulation around the cylinder liner, or we can say our cylinder, then it is dry liner, and around the liner water is circulated for absorbing the heat within the chamber, then it may be wet liner. Now next part is piston. It is a cylindrical part closed at one end, which maintain a closed sliding fit in the engine cylinder. Means this piston is, we can say, closed at one end, and that is called the top or crown of the piston, and this piston slides in the engine cylinder in the reciprocating motion. It is connected to the connecting rod by a piston pin. See, this is the piston. Here, this is the piston pin. This is the hole in which piston pin is inserted, and piston is connected with the connecting rod from this piston pin inserting in this hole. The force of the expanding gases against the closed end of the piston forces the piston down in the cylinder. Means cylinder reciprocate in the piston reciprocate in the cylinder. So as and when burning of the fuel takes place during the, we can say, power stroke, then due to the burning of the fuel, there will be expanded gases inside the combustion chamber, and that expanded gases force the piston, or we can say crown of the piston or top of the piston, downward in the cylinder and produce the power or transmit the power to the piston. This causes the connecting rod to rotate the crankshaft. Means piston is connected through the connecting rod with the connector to the crankshaft. So whatever we can say force that has been applied by the expanded gases on the top of the piston, that has been transmitted by the connecting rod to the crankshaft in the form of rotary motion, because piston rotate reciprocating motion, but it has been transmitted by the connecting rod to the crankshaft in the form of rotary motion. Now, mostly it is made of means what is the material that of the we can say piston? Mostly it is made of cast iron due to its high compressive strength, low coefficient of expansion, resistance to high temperature, ease of casting in low cost. These are the characteristics of cast iron. See, we know that cast iron has good compressive strength. It has low coefficient of expansion. It's, as and when it receive the heat, then it will not expand much more. Because its coefficient of expansion is low, then resistance to high temperature means due to high temperature there will not be wear and tear or any type of deformation in the cast iron. So it has resistance to high temperature. Then ease of casting means it can be casted easily. So we can produce number of we can say piston in the factory, and the cost is also low. Aluminium and its alloy preferred mainly due to its lightness. Means if you want to produce our engine with light in weight, then in that case we must go either for aluminum or the alloys of the aluminum, because it has less weight. So for in some cases, if we want to produce light in weight engine, then our piston must be either aluminum or aluminum alloy. See, in the piston, there are generally 3 piston rings. This is the top portion. It is called the crown of the piston. The piston slides in the cylinder, or we can say within this cylinder block, where cylinder sleeve is there. This is the cylinder liner. Here in the piston there are 3 rings. Top ring is, we can say, top compressive ring. Then second ring is second compression ring, and third ring is oil ring. This top and second compression rings acts as a compression ring, which do not allow the burnt gases to escape from the cylinder to the outside with the sliding motion of the piston. And this oil ring do not allow the oil to go in the, we can say, cylinder liner. Now, 6th part is the connecting rod. Connecting rods connect the piston to crankshaft and transmit the motion and thrust of the piston to crankshaft. Means connecting rod connects 2 components. First, it connects piston, and second, it connects the crankshaft. Means one end is connected with piston and another end is connected with the crankshaft, and through which whatever reciprocating motion of the piston is transmitted to the crankshaft. It covers the reciprocating. It converts the reciprocating motion of the piston into rotary motion of the crankshaft. Means this connecting rod convert the reciprocating motion of the piston. We know that the piston is reciprocating in the cylinder to and fro motion. So piston is in the reciprocating motion, but this connecting rod convert this reciprocating motion of the piston into rotary motion of the crankshaft. Means crankshaft is rotating in the rotary motion. There are 2 ends of the connecting rod. One is known as big end and another as small end. Means connecting rod has 2 ends. One end is, we can say, small end, and another is called big end. Big end is connected to the crankshaft, and small end is connected to the piston by the use of piston pin. See, this is the small end. This small end is connected with the piston pin, or we can say sometimes buzzer pin. So this is the small end, and this is the big end. This big end is connected to the crankshaft with the suitable arrangement of connecting rod bearing cell and connecting rod cover with the crankshaft bearing. The connecting rods are made of nickel, chrome, and chrome vanadium steels. Means different types of materials are used for constructing the connecting rod. It may be nickel, chrome, or chrome vanadium steel. For small engine, the material may be aluminum. Means if we want to make small engine, so to reduce the weight of the engine, and maybe there may not be more low thrust load to transmit by this connecting rod from piston to crankshaft. So in that case, aluminum may be used for manufacturing the connecting rod. Now we will see the crankshaft. The crankshaft of an internal combustion engine receive the effort or thrust supplied by piston via connecting rod. The reciprocating motion of the piston is converted into rotary motion of the crankshaft. As we have earlier seen that reciprocating motion of the piston is converted into rotary motion of the crankshaft via, we can say, connecting rod or by the connecting rod. The crankshaft mount in the bearing, so it can be rotated freely. Means our crankshaft is mounted in bearing in the crankcase. Therefore, due to the bearing, there will be no friction and frictionless rotation will be there of the crankshaft. The shape and size of the crankshaft depend on the number and arrangement of cylinder. Means the shape and size of the crankshaft depend upon number and arrangement of cylinder. Means if our engine is, we can say, 4-stroke, 4-cylinder engine, then we must have 4 space for connecting rod to connect with the piston. If our engine is, we can say, 6-cylinder, then there must be 6 space for connecting the piston to the through the connecting rod to the, we can say, our crankshaft. So depending upon the number of cylinder and its arrangement, the shape and size of the crankshaft may be different. It is usually made by steel forging. Means generally material for constructing the crankshaft is steel forging. See, this is the, we can say simply our crankshaft. In the crankshaft, this portion here connecting rod is, we can say, big end of the connecting rod is joined through the, we can say, crankshaft bearing. This crankshaft rests on the crankcase with the crankshaft bearing for the frictionless movement. Now, another part is crankcase. The main body of the engine to which the cylinder are attached and which contains the crankshaft and crankshaft and crankshaft bearing is called the crankcase. Means the crankcase, we can say our crankshaft and crankshaft bearing are attached. So see here, this is the crankcase, or we can say oil pan, or sometimes we can say oil reservoir. So this is the crankcase in which the crankshaft and crankshaft bearing are attached for the frictionless movement of the crankshaft. It serves as lubricating system too, and sometimes it is called the oil sump. See here, in the bowl type container, oil is there. So it's this oil sump, or we can say our oil pan, will be useful in the lubricating system. All the oil for lubrication is placed in it. Means in the oil pan, or we can say in the crankcase, oil is filled. So this oil is used for the lubrication system. Now, next part is camshaft. Camshaft is used in the IC engine to control the opening and closing of the valve at the proper timing. As we will study during the 2-stroke and 4-stroke engine, in the, we can say, in the suction stroke, during this suction stroke, when piston moves from the top dead center to the bottom dead center, at that time inlet valve or suction valve is open and exhaust valve is closed. So this opening or closing of the valve, either it is suction valve, or we can say inlet valve or exhaust valve, that that can be maintained through the camshaft mechanism. So camshaft is used in the engine to control the opening and closing of the valve at proper time. Means at proper time, inlet valve must remain open. At proper time, it should be closed. At the exhaust stroke, to expel out the burned gases from the cylinder, the exhaust valve must be open, and at certain time when exhaust stroke completed, then exhaust valve must be closed. So this opening and closing of the valve is done by the rotation of the camshaft by suitable timing. For proper engine output, inlet valve should open at the end of exhaust stroke and close at the end of intake stroke. Means for taking out fresh air, in case of we can say four-stroke engine, or we can say our diesel engine, at the starting of we can say our suction stroke, or at the end of exhaust stroke, inlet valve should remain open, and after end of the intake stroke, or we can say our suction stroke, inlet valve must be closed. So to regulate its timing, a cam is used which is oval in shape, and it is expected it exert a pressure on the valve to open and release to close. We will see in the figure. See, this is camshaft. In the cam, this is the globe known as cam. So this cam or oval shape arrangement exert the pressure to the valve. Through this pressure, either at the time of exerting the pressure, valve opens, and as and when this globe cam goes down, then it releases the pressure, and then valve close. It is driven by timing belt, which drive by crankshaft. We will see in the figure. To drive the camshaft, there is a arrangement of timing belt, which takes power from the crankshaft and rotate the camshaft. It is placed at the top or at the bottom of the cylinder. It is placed either at the top of the cylinder or at the bottom of the cylinder. Here, this is our crankshaft gear or camshaft socket. This is our crankshaft, and this is our camshaft. So power to rotate from the camshaft is taken from the crankshaft through the either crankshaft gear or sprocket gear joining with the camshaft gear or camshaft socket with the timing chain. This is the cam, or we can say the portion that is extended that lifts the valve push upward, and that upward motion goes to the rocker shaft and pushes the rocker arm downward, and that pushes the valve inside the we can say cylinder, so valve open. So as and when the lobe of the camshaft or the lobe of the cam come in touch with the push rod, then it pushes upward, and that upward motion is transferred through the rocker arm and spring mechanism, and thus it pushes the valve stem downward, and this valve open in the cylinder. So if it is inlet valve, then at the time of suction stroke, this valve pushes inward, so this open the hole, and whatever gases, suppose this is our inlet valve, so in that case if the inlet valve open goes downward, then inlets through the inlet space fresh air comes to the cylinder. After we can say power stroke, if in the exhaust, during the exhaust stroke, burnt gases must go out through the cylinder. So in that case, in that time, our exhaust valve opens with the downward movement. the cylinder, and exhaust gases goes out from the cylinder. So this is, we can say, a valve operating mechanism which allow the less air to enter inside the cylinder during the suction stroke or inject stroke, and expel the, we can say, exhaust gases from the cylinder during the exhaust stroke in the four-stroke engine. Now, next is the valve. To control the inlet and exhaust of the internal combustion engine, valves are used. The numbers of valves in the engines depend on the numbers of cylinders. Means for each and every cylinder piston assembly, there may be two valves. One is inlet valve and second is exhaust valve. Two valves are used for each cylinder. One for inlet of the air-fuel mixture inside the cylinder, and another for the exhaust of the combustion gases. The valves are fitted in the port at the cylinder head by the use of strong spring, as we have seen earlier on the figure. This spring keep them closed. See, this is the spring which through the pressure it generally keeps the valve fit in the hole, but as and when the cam pushes the push rod, and that upward motion is transferred to the spring, and by compressing the spring, the valves open in the cylinder. This spring kept them closed. Both valves usually open inward, means both the valve opens inside the cylinder. Now, next is flywheel. Camshaft is used in IC engine to control the opening and closing of the valves at the proper time. A flywheel is secured on the crankshaft. See, this is inside. This is the extended portion of the crankshaft, and over this flywheel is attached. This is the, we can say, four-stroke IC engine. This is our ordinary diesel engine. So size of the flywheel is big. In the two-stroke engine, flywheel has less weight and size is less. The main function of the flywheel is to rotate the shaft during preparatory stroke. Means this flywheel store the energy which is produced during the power stroke, and it supplies during the ideal stroke. It may be suction stroke, or we can say compression stroke, or we can say exhaust stroke. So these three strokes are ideal stroke. Power stroke is only the stroke in which energy is produced. So this energy is stored in the flywheel, and this may be supplied either for the ideal stroke as well as for the further useful work in the transmission linkage. It also makes crankshaft rotation more uniform. Means due to explosion of the burnt gases, there will be production of shock load, and piston will reciprocate with the, we can say, more RPM. So there will be shock load on the piston, connecting rod and crankshaft, but whatever more power that has been produced by the engine, that has been stored in the flywheel, and it smoothen the power. So crankshaft rotates